In this session, you will be learning about Arduinos, current sensors, and IDEs. To start, an Arduino board is a simple computer with no operating system. An operating system is the interface you use to interact with computers such as your laptop or smartphone. So instead of using an operating system to run, we will provide machine code from our computers to the Arduino. Machine code is a type of programming language that machines and computers use to run processes at the most basic level. It is written in binary or ones and zeros. We achieve this by programming in C++ code, and the software will convert it to machine code for the Arduino to read and use. This software is called an IDE, which stands for Integrated Development Environment. The great thing about an Arduino is that we can connect a multitude of components and sensors to create whatever we want. Here are a few examples of what some people created using Arduino. On the left is a biking jacket that automatically gives a turn signal to drivers behind. The top right is a door lock that will unlock only when a specific knock is given, and at the bottom is a robotic arm controlled by an Arduino. Here is a standard Arduino Uno board. As you can see, there are two ports for power. The power USB is where you plug into your computer and upload the machine code. The barrel jack, however, only provides power. The power out pins can be used to power your circuits. The analog pins connect to sensors that use light or audio. As for the digital pins, they connect to sensors that output in binary, or zeros and ones. We will be using these pins to communicate with the Bluetooth module. The SCL and SDA pins help with communicating with sensors that need to take data during specific time periods. We will use these to communicate with the current sensor. This is the current sensor you will be using in your device. It provides the voltage and current of the solar panel we will be attaching to it. The current sensor works by either measuring the voltage drop at the position where it is placed in the circuit, or measuring the magnetic field generated. We will be wiring the Arduino board, solar panel, and a small series circuit to the pins indicated above. Now you will begin a small activity that introduces you to coding an Arduino on its respective IDE. Start by connecting your Arduino to your laptop and running the IDE. Then go to File, Examples, Basics, and try out the codes named Blink and Fade. Read the description for each and experiment with them. A small challenge you could try is to alter the frequency of the flashing of the LEDs on each. We'll be using the Arduino and using the scripts Blink and Fade. What we'll need is a laptop with a USB cable here. This one's going to the laptop, and this one's going to go to the Arduino. We'll need an Arduino Uno, breadboard, resistor of your liking, preferably over 200 ohms, an LED, and two wires. So let's plug it into the laptop. Plug it into the Arduino. As you can see, the green LED inside shows that it's on. Now we'll go to the Arduino IDE. Just wait till it opens. I have Fade already open, but let's do Blink first. So go to Examples, Basics, and Blink. Pull this up. Good thing to do is go to Tools first and make sure that the port is the correct one. So I'm using the correct one so we can continue. You can read through it, but what this is doing is that we're calling the built-in LED, and we're going to be turning it on and off. So let's compile it and upload it. As you can see, small light right here is blinking on and off. What we can do is change the delay to a smaller number. Let's do 300. Compile it. Upload it. And you should see it's blinking a little faster. We can even change it to something a lot smaller. Let's say 100. We should see a bigger difference. As you can see there. Now let's try the fade. So go to Examples, Basics, click on Fade. Pull it up. And you can see that we're using the pin 9 established here with the variable LED. And we're declaring it here. So we're using pin 9. And we're changing the brightness and using some fading. So what we're going to do is have a wire going from the 9 pin, seen there, connecting a wire, putting it onto the breadboard. Have a resistor, then LED, creating a simple series circuit. Oh, it's not going, one sec. There. Connect the last wire from the end of the LED, connect it to ground. Now, we're going to compile and run it. As you can see, it's fading on and off. We can actually try to take the resistor out and see if it gets a little brighter. You usually don't want to do this because it's applying too much power to the LED and it would burn out. But the Arduino actually does something where it doesn't allow that. So it gets a little brighter if you want to see it. Let's try changing the delay a little bit. Let's try 5 actually. See if it changes anything. So you can see it's doing a little strobe now. And that's blink and fade. Your next activity is soldering the current sensor together and wiring it to a 9-volt battery, series circuit, and an Arduino. You will first begin by soldering the 3 pieces of the current sensor together and placing it on your breadboard. Next, you should have wires from the 5-volt pin of the Arduino to the far left pin on the sensor called VCC. Next to the VCC, the GND, or ground, shall go to the GND on the Arduino. The SCL and SDA pins on both the current sensor and Arduino shall connect together. After you finish that, create a series circuit with a 20 ohm resistor and an LED from the VN- of the current sensor to the established ground you created on your breadboard. Lastly, attach the positive wire from the 9-volt battery to the VN positive on the sensor and the negative wires to ground on the breadboard. In this video, we'll be wiring and soldering the current sensor, Arduino, in a simple series circuit. What you'll need is a 9-volt battery, couple wires, Arduino Uno, a current sensor that's also a voltage sensor, a 200 ohm resistor, I'm using 220, which should be okay, an LED, circuit board where we can solder, a screwdriver, some solder, and a soldering iron. So we'll begin by soldering the current sensor together. There's 3 pieces. We're going to take the one with the most prongs, and the smaller the sides, we're going to go through the bottom of the current sensor, and it should look like this. Now, we have to be very careful and solder each one of these and make sure that they don't touch. So let's get started. Okay, that should be good. Look how you did. Actually, I might want to solder this a little bit more. We have to make sure that there's full contact. This one needs a little bit more too. Okay, that should be good. Now we're going to take the other piece and we're going to put it from the top down and have this piece facing outwards. Turn it around. We're going to solder those 2 pins. And we should be good. All right, now that we have the current sensor soldered, we're going to add it to the breadboard and have a series circuit connected to this and have all the wires go into the Arduino. So let's take our current sensor with these little prongs here. See where we should put it. Let's put it here. Make sure there's holes next to these pins because those are where the wires are going to be connected to. So turn it over and let's solder each of one of these pins. Make sure that none of them connected to each other, only on the row of the circuit board. Where is it? There we go. Okay. See how we did? Yep, they should all be connected. Awesome. Now, let's add our LED. We're going to take the longer side of the LED and going to place it into the VN minus on the current sensor in one of these holes. We're going to take our screwdriver and screw it down till it's pretty snug. Let's see if I can put it in there, 1 sec. Okay. Hold it down. Oh. I'm actually going to use a different screwdriver.
To like you actually having it done, so don't worry about how long it's taking you. Just show the output when you're done.
Now that we have screwed it and it's attached pretty well, we can take the other side and solder it into the closest hole. Make sure nothing else is attached to it though. So now, we can bend it a little bit. Now we're going to solder it in place. Good. Now let's add our resistor. Connect it in the same row as the smallest pin of the LED. Place the end of the resistor in another row that's not connected to anything else. So now we're going to solder those together. Solder this one. Awesome. Now we have that. Now, let's add the 9-volt battery in and establish our positive and negative for the circuit board. We'll have the positive going on this side and the negative on this side. Let's flip that around. I can see that I have some solder, so I'm going to unsolder a place here. There. So let's put it in there. Yours shouldn't have any other solder here. This is just some stuff I worked on before, so it should be a little easier for you. So let's solder this point on. Let's give it a second to harden. Do a little pull. Good. Now let's attach to the ground. Oh, nope, I want to attach it to this side. Solder it in place. Take a little bit more out. Give it a second. All right, that should be good. Now let's take a small wire, actually a little bit bigger, and we'll connect to this end of the resistor that's not attached to the LED and attach it to ground. So there's actually a full circuit here. So I'll have it on the same row. Have the other side connected to the vertical so it has some ground. Let's turn it around. Let's solder these. Should be good. Now let's there. Awesome. We're actually gonna, I kind of screwed up here, but this is actually supposed to go into the current sensor here. So this might be a little good lesson, but we're gonna have to unsolder this here. Oh, and it just pops right out. You just gotta give it a little tug as you unsolder it. Just make sure that you're not touching any of the wire here or it'll burn you. So now, we're gonna take it to the current sensor here. Give it a little twist so it's a little thinner. And then we're gonna put it in here and the LED should light up. So just stick it in there and take our screwdriver. Make sure it's fastened. Awesome. That's good. Now we can actually, it's finding the voltage and current from the 9-volt in the load here. So now we have to actually attach it to the Arduino through the pins here. We're going to be using the VCC, GND, SCL, and SDA pins. We're not going to use the VN minus and VN positive here. We can leave those alone. We're going to use only these 4 pins. So take one of your wires, and let's do the VCC first. Because the VCC is attached on the same row as this one, we can just add it here. And that's what we're going to do. Have it here. You can see that they're touching.
Lean it forward toward the camera so I can see. Okay. Perfect.
And let's solder it. Oh, it popped out, but let's put it back in. And it should be good. Now let's add the ground. Here. You can bend it towards the pin of the current sensor to make it easier for you to solder. Oh, make sure it's not connected to any other pin, only the pin you want it to. So we have that. Let's add 2 more wires to the current sensor. We're going to put the wire in the SCL hole and bend it towards the correct. Bend it towards the correct pin. Well, as best as you can. Now carefully solder it. There. Let's check if it's good. Nothing touching unless only the pins that we want. And we'll add the last wire for the current sensor, for the SDA pin.
You should flip it so they can see the front.
Right there.
It should look like this. Something like that.
It should look like this. Okay. The hardest thing when doing this is that you have to make sure that only the correct pins should be touching. Otherwise, it would not work. Only the ones on the same row. This one's a little tricky. Oh, and there we go. Awesome. So now that we have that, we're going to go to the Arduino now. And we're going to have a wire for the VN, actually the 5 volts here, and one for the ground. So actually, that's where the wires are going to go. But let's first establish the 5 volts here and the ground here. So let's do that. Put a wire. Oh. Let's open up a space here. All right. Now let's put a wire in there. Let's solder it in place. There we go. Now let's take another wire and create a ground for the whole circuit. Place it in one of these holes. Turn around. Do a little bend. And solder it in place. There we go. Awesome. So we have all the wires we need. Now we have to connect it to the Arduino. We're going to have the positive wire connect to the 5 volts on the Arduino. as you can see here. Now, let's take the ground from the circuit board to any one of the ground pins on the Arduino. I'm going to put it to this one. Now, we'll take the SDA pin, place it right here, which is the second one to the end. Take our SCL pin and place it on the end one. Now that I have that, we have to power the current sensor. Now that we have a connection for 5 volts going here and a ground here, we have to take the wires from here, connect the VCC to the 5 volts on this vertical row, and have the ground going to this one. So let's just do a little bend. Try to find a hole that we can attach it to. Let's find one. Oh, found one right here. Do a little bend. Let's see. Up, it's not. There we go. Went through. Good. Now let's solder it in place. So looking at the circuit board, I actually soldered, let's see, I soldered the ground to the 5 volts here, where it should actually go to this place. Dealing with circuits, this usually happens a lot. So let's unsolder this part. Hold it, do it, give it more tugs, and oh, this one's a little more tricky. Okay. And it should pop out. Just give it a little time, and it'll come out. So now let's add it to the actual right side, which is this row or column. Place it here, put it there. Now add some solder. Let's see how we did. Going from there, ground. Awesome. Now let's take the VCC of the circuit board and place it on the correct one where the 5 volts is going to be established. We're going to put it in the hole we just actually took out. Bend it a little bit. Solder it in place. All right. Now let's go over what we just did. So we soldered the current sensor together, we soldered it to the circuit board, and had 4 wires going from the circuit board that's attached to the pins on the bottom from the current sensor, as seen here. 2 of them we're not using, but you still solder them in the same row just to keep it some balance. Now the VCC goes to the 5 volts here that's established with this wire going from the circuit board to the Arduino here. We also have a ground going from the current sensor to here, where the ground is established from the circuit board to the Arduino in one of these pins. We have the 9-volt battery with the positive going into the V in positive on the current sensor and the negative for ground to the ground here. Our simple series circuit, the longer part of the LED goes into the V minus here, and we have a 200 ohm, or in my case a 220 ohm resistor touching the smaller piece of the LED and put it into a pin that will then go to ground. In the last part, we have the SCL and SDA wires going to the Arduino, with the SCL going to the end row here, and the SDA pin from the current sensor going through the wire to the one right next to it. And there we have it. After you finish building the circuit, you will begin coding the Arduino in order to take readings from the current sensor. First, plug in your Arduino and run the IDE. Next, open File, Examples, Adafruit i9A219, and then Get Current. Briefly skim through the code and think about what it is doing. Lastly, upload the sketch and click on the serial monitor icon on the top right, and you should see new measurements every 2 seconds. Okay, now that we have the whole circuit assembled, we're actually going to program the Arduino to find out how much current and voltage is going through the load resistance here. So let's take our USB, plug it into the laptop, plug this end into the Arduino. Should turn on. Let's go and click on Arduino IDE. Before this, you'll need to download a library, but you'll be able to see that on our website. So we're going to go to File, Examples, go all the way down, click on Adafruit INA219. Get the sketch, Get Current. Pull this up. Take a look what we're going to be doing. We're going to find the bus voltage, shunt voltage, load voltage, and current. So we're going to compile it and upload it. We're going to go to the serial monitor in the top right. It's actually good for you to see. You have to, looking back, the baud rate here is 115,200. So when we're doing serial monitor, let's go to that. Where is it? Right here. We have to change it to have the exact baud rate. And now we should see the actual voltage and current without any of those weird characters. So this is what you're getting, and the numbers are gradually changing, never staying the same. You should have something working. Now you're going to start your first construction of the device. You did most of the wiring from Activity 5, but there are a few things you still need to do. First, you will be attaching the battery holder to the case and sending the power cable through the larger of the two holes. Next, replace the resistor with a resistor with a value between 2 kiloohms to 5 kiloohms. Lastly, disconnect the 9-volt battery wires from the circuit. In this activity, we're going to be putting the 9-volt battery holder onto the case. We're also going to change the resistor that we have here from our last circuit with one that's around 4.7 kiloohms. The last thing we're going to do is solder and remove the 9-volt battery, because later on we're going to be swapping this for a solar panel. So what we're going to need is the case that you can find on our website with the specific holes drawn here. 9-volt battery case, the circuit and Arduino we created in activity before, a piece of double-sided sticky tape that has a little foam between them, and of course soldering iron, some solder, and a resistor that's around 4.7 kiloohms. So let's take our sticky tape, place it on the side that's not where the switch is. Let's place it right about here. Push it down, take the other side off. So now this side is sticky. You see the two holes here? We're going to place this with the wire closest to the holes. So place it right here. See there? Take the wire, place it through the bigger hole. When we're finished, the Arduino is going to be doing most of the stuff, and we don't need to connect it to the computer anymore because we're going to be powering it through this. So let's set that aside. And let's unsolder the resistor. There. There. Let's take that out. Let's add the new resistor. So let's go over this again. We're connecting one side to the LED. If we can put it through there, we're going to need to unsolder that, but the other side is going to go to where the wire is here that goes to ground. So we need to first unsolder those places so we have a place to put it. Okay, now let's unsolder this part. There we go. Now let's put it through. Straighten it out. Let's try to feed it through. And it should go in. Now the other part to the wire here. Move it out of the way. Turn to the other side. Bend it and bend it. So now we can solder it. There we go. Now let's remove the 9-volt battery. Let's start by unscrewing the positive side out. There we go. Last but not least, let's remove the ground wire right here. There we go. I'll take this out. We're left with this. And now we're going to be doing some changes, and then we can afterwards put it into our case here. This completes session 2 of the Current solar panel program. I leave you with this quote: "I have not failed, I've just found 10,000 ways that won't work."